Today we're going to talk about how to install the TMC 2130 with sensorless homing on the SKR version 3. So there's a couple of things I need to point out real quick on this for you so you can see what's going on. First, we have our X stepper, our Y stepper, our Z stepper, our E0 stepper, and our E1 stepper. Now, of course, there's ports for them over in here, and I believe there's 2 for the X stepper over in here. But we can check that out on the diagram. The other thing that we need to know is that there's a very small jumper that we need to place here for sensorless homing. So if you decide not to do sensorless homing and use end stops, then you would leave this jumper off over here. So first thing I'm going to do is actually show you how to install the jumper for the X-axis. Now it's kind of difficult to do with your fingers. Obviously your fingers are somewhat too big. So what you're going to need to do is grab some of these. And give me a second to put this back on here. Sorry, it just takes a second. Then you're going to slide it right in here. And that will take care of it with these. So the next thing that we need to do is we actually need to install the stepper. And as you can see with sensorless homing, we actually have extra diag pins over here that will route through the actual tracings of the board. So in this case, you see yellow on one side, black on the other. So the yellow side obviously is going to match up to the pins. Now normally you would have a heat sink over here to wick away the heat, and you'd probably use a cooling fan, but I've covered that in previous tutorials. So if you're interested in knowing how to do that, it's in the playlist in the description where it talks about cooling fans for the actual board. So the next thing that we need to do is obviously remove the actual SD card. We're going to have to put it in an SD card reader, and we're going to have to learn some things about the board. So I'm going to insert this in the computer. You may hear a beep. And obviously at the moment, normally when you run TMC type steppers, you don't run with your actual jumper connection for USB here. But in this case, I'm going to leave it until we load the firmware, then I'm going to extract this. So in this video, I will make some mistakes on purpose to show you things other than what's occurring in the actual normal setup, because I could show you the straight through way to do this, but I want to show you what is occurring. So in a second, we'll go over to the computer and we'll see what we can see. So on the computer, we're going to have to find in the Bigtree Tech GitHub repository our actual board type. So we're going to type SKR 3, and that will bring up our configuration. Pardon me, I got to do it in all capital letters here. And I'm missing the dash, but that's okay. So as you can see here, we have the Easy manual, which is the same board except a different configuration. And then we have our SKR3 user manual. So inside of here, what we're going to do is we're going to scroll down. Obviously, you can see the board much better here with the SKR3 and the jumpers that I was talking about for sensorless homing. But we're going to scroll down and we're going to go to the configuration of the TMC driver type for SPI. That's what the TMC 2130 is, and SPI means Serial Peripheral Interface. It's basically a wiring scheme and a programming method to communicate with your unique stepper. So it's kind of like a mailbox that you point to and send commands. But I'm not going to go into that too much in this video. So I'm going to scroll down and I need to advance to page 12. So it's going to take a second to get to, so I'm going to scroll really quick. But as you can see, there's other configurations when you get down to about page 10. But the one we're interested in is actually SPY. So as you can see, the driver SPY mode, and this explains the jumper configuration. So if we go back over to the workbench for a second, you can see that the actual jumpers that I have here are in the default as you would get your board. But if not, you can always move it. So I'm going to pull this out for a second so you can verify what I've done. And then I'm going to place this back on here. So now that we have that sorted out, let's go back and see if there's anything else we need to worry about. So down here, we don't have to worry about removing a diag pin, but here's the sensorless homing that they were talking about for the diag pin. This essentially shorts it so that it will work correctly. So what I'm going to do now is I'm going to go over to VS Code, and I'm actually going to open a downloaded and freshly extracted Marlin software. So I'm going to go to my downloads folder, and here's the extracted Marlin. We have to go one more folder deep, so it's Marlin 2.11, Marlin 2.11, and then select folder. So inside of here now, this will take a second to load. And as you can see, the default environment currently is the Mega 2560 for ramps. We'll have to fix that in a few moments. But what we're going to do is we're first going to go over to the configuration folder. And what we need to do is go to the source, core, and then boards.h. Inside here, we're going to search on skr_v3. Whoops, apparently I'm searching in the wrong place here. So it's over here. So it's Control F, then skr_v3. And that'll bring us to our board type. So we can copy this, then we can minimize this folder and the source folder, then go to configuration.h. Inside here, we just need to scroll down and find motherboard. And as you can see, the motherboard currently is on the ramps, so we're going to paste over that. Then what we're going to do is we're going to change the serial port, in this case, to -1. Now, a lot of people like to tell me that you should do it down here, but I like to do it here because this is the actual board that we're working with. And then I usually use this one for like the TFT display. Now, obviously there's a third one, but currently we're going to only work with the motherboard. So now that we have that set, we're going to search on A4988. This will bring us to our steppers. So we're going to search, or excuse me, copy the TMC 2130 and paste it right here. Now the next thing that we need to search for is steps per unit. And the reason that we do this is it comes at a default configuration. This is going to matter if you want to increase the resolution of your steppers. So if we were to go over to configuration advanced and we were to search on, we'll say 800. I'll show you this real quick. So for the X currently we're going to just leave it at 800. That's a root mean square computation. Basically, it's the square root of 2 right here. And that's used to actually calibrate to what we're using. So we're going to go with the default for the moment because we don't need to readjust it. And you can see right here microsteps. And microsteps allegedly go from 0 to 256th of a step. So if we were to change, in this case, 80 to 160, we would also need to change this over here to 32. Now, if we were to increase the resolution even more, we would need to go back over here and let's just say we want to make this 360, which would give us 1/64th of a step. So it's first 1/16th to 1/32nd, and then this number would give us 1/64th of a step. So we change this to 64. Now I'm showing you that so that you understand that it's proportional. Anyways, let's go back over here now that we've adjusted that, and we're going to search on, let's see, invert dir. And I want to show you this because sometimes your actual axis will go in the wrong direction. If you change this from a false to a true, it will change the direction 180 degrees from where you think it will move. Sometimes you'll need to do that. At the moment, I'm not going to change it. So let's go back over here and set up sensorless homing. But before we do that, we want to turn on TMC_debug. Normally, when you're running this, you can turn this off in the future. But I just want to show you what's going on for TMC debugging. So this will be turned off after you've fully configured this, but it's a great way to troubleshoot. So those are both on, and as you can see, we can now use the M122. This will actually work without the debugging on, but the reason I enable it is to show you that it exists. You should disable after complete. So now we're going to search on sensorless homing. So Control F, then we're going to say sensorless. And that'll bring us to sensorless homing when we do the underscore. So here we are. In order to use this, we need to do a Control / or remove the 2 slashes in front to enable it. And this will become enabled in just a second. So what I've discovered is this is where I'm going to show you a mistake on purpose. The old default used to be 8 for the sensitivity. This has now changed, but I want to show you this error so you know how to troubleshoot it. So I'm going to leave it as is. So let's set up the build for the moment, and then we'll go back. But there is one last thing I want to show you for SPY, and that is we're going to have to search on SPY software _ SPY. And we need to enable this to use SPY. Now this works off of pins. Basically, these are the pins that we're using, and they're on the actual stepper, but they're already basically specified in your pins file. So if you go over to source, then you go to pins, and we search on the actual type of processor we're using, which is probably the H7. You'll see inside here the BigTreeTech SKR version 3 common. Now what that means is that these two different files have a modification off of this, so they override it. So in here is where the majority of your pins will be found. And as you can see, here are diag pins for our X end stop, so it knows where it is if we're using Trinamic with stall guard pins. They also outline the pins down here, like the chip select. When I was saying with serial peripheral interface, this is your mailbox number. So in this case, this specifies PD5, which is the pin number on the board to say talk to this. Now obviously I'm not going to go into much more detail about this, but there's plenty of reading out there. So let's go back and set up the actual build like I was going to do a second ago. So I'm going to minimize this. I'm going to minimize the actual source folder, and I'm going to go back over to Platform IO. Now what you can see in here is that it's the Mega 2560. So I'm going to click on the INI. I'm going to find our board, which is this one right here for the actual processor type, or MCU. And I'll show you real quick what that is. So if we go over to the board for a second, the MCU on it has that actual writing on it for STM32, and then it's probably H or G7. I can't see it from here, obviously, but let's go back over here and select it. So I'm going to scroll down, and I'll find our board, which is right here. This is our environment, so I'm going to copy it. And as you can see, it says that it's the STM32H743. So I'm going to minimize the INI. Then I'm going to go over to platform.io.ini, and I'm going to paste our environment in here. Next, what I'm going to do is I'm actually going to do a clean so that anything that was previously in the .pio folder is removed. So now it's prepping or priming for our board. So you can see that it's successful. So I'm going to click on the build checkbox. Now keep in mind, while it's building, in this case it's downloading or unpacking stuff that we're going to need for our build. If it does fail, fix the very first error you encounter. That way all the other errors thereafter might be a cascade, and we're about to see an error any second. So now that we've seen an error, what you can see right here, we're going to find the very first one, and in here it says something about sensorless homing and that the X minimum needs to be inverted or equal to true. So they're talking about configuration.h, so I'm going to hit the copy button right here. I'm going to go to configuration.h, and I'm going to do Control F, then Control V, and as you can see it's set to false, so we'll change that to true. That takes care of the issue that we're seeing right there. The next issue I'll show you in a few moments, but let me build this first so you can see that it takes care of that error. The next one's going to be somewhat more nuanced, we'll say. So this should build somewhat quick, and we can watch this in the .pio folder right over here in the build, and we'll see that there'll be a firmware.bin being a binary firmware file that we can use to load on our board. So we'll give this a second to actually display it after the build completes. So it's pretty close. You'll probably see a firmware.elf in a moment, and that is actually for troubleshooting. So the next one will appear. We'll right click, we'll reveal in File Explorer. Now if you click on the USB, here's the past thing that loaded successfully. That's why it's in all capital letters and .cur. So if I go back over here, I'm going to right click and I'm going to say send to, and I'm going to send it to that drive. So if it's successful, it'll be renamed to this. But if you ever need to reload it on the same exact system type, you could rename it to this. So I'm going to pop the drive out, and I'm going to actually install it now into here. So what I'm going to have to do is I'm going to have to plug it into here. Once it's in here, I can actually load it with the USB. So this has currently got the jumper on. So I'm going to plug this in. We'll hear a beep in a moment if it's successful. Then we can unplug it. I'm going to pull this out so you can see that this is the way it's supposed to run when it's using a TMC type stepper and the board won't power. So what we're going to do next is actually set up the power. Obviously it's unplugged from the power supply, meaning the wall is not energized when I'm doing this operation. So I'm going to take the actual leads for this, and they're going to go right in here according to the colors I marked on it in previous tutorials. Now if you're unsure what you're doing, verify in the manual, or you can use the Discord that I have set up to ask people questions. Most people in there are very familiar with how to use these boards. So I'm going to screw this in like so, and I'm using ferrule connections for safety. These crimp on and provide a safe way to encapsulate the wires so they're not hanging out and accidentally touch something they shouldn't. So I'm going to slide the other one in, and I'm going to tighten that down. And as you'll see in a second, these don't pull out very easy. Next, what I'll do is I'll connect the actual stepper over here to the port. Now if you want a reverse direction, you can always flip this 180 degrees, but I choose not to do that. I do it in software. So I'm going to plug this back in. Obviously it's not going to connect to anything until I energize the system. So I'm going to energize the system now by plugging it in. Now what you can see is that it's actually powered. So we're going to go over to Pronterface in just a second. So give me a second here to set this up for you. Okay, now that we're actually in Pronterface, what I need to do is I need to find the actual COM port, because currently it says COM port 1. Now to verify it, it might be COM port 5, but we can verify this by doing a very simple operation. So I'm going to go over to the actual desktop for a second. I'm going to then type Device Manager, and this will bring up the actual Device Manager. We can click on Ports, and you can see that it's COM port 5 for the STM Microelectronics Virtual COM port. So I'm going to close out of this. I'm going to set this to actually 5, and then what I'm going to do is I'm actually going to connect to the actual board. So I'm going to click Connect. Now that we're connected to the board, we can actually do an M122 to verify that it's okay, as you can see right here. So the next thing that I want to do is advance this by 10, and it works. Now let's go back 10. Now homing is going to be an issue. So I told you there was a mistake. So this is what you're going to learn, because originally it was 8, it no longer is. So let's home it. So you hear that grinding noise? That means it's not functioning correctly. So the sensitivity is off. So I'm going to unplug the system for a moment. Let it de-energize. Move this over to the center for a second. Then I'm going to go back over to VS Code in just a second. But before I do that, I need to extract the actual thumb drive. So I'm going to take the thumb drive. I'm going to place it back in here. And we only need to make one modification. So we'll go over to the desktop for a second. Then we'll go over to VS Code. We'll go to the advanced configuration. And we'll search on sensorless homing. And I think I need an underscore in there. And as you can see, it's 8 currently. The actual value is probably going to be closer to 2. And you'll see why in just a second. So I'm actually going to rebuild this with the checkbox. We'll give it a second to actually show up in here again. So this will be an actual fresh build that will overwrite this in just a second. So we'll give this a second. And what we can actually do is probably cheat and go over to here. But I want to show you the updated file. So I'll let this finish. We're only changing one value, so it probably will compile quicker, only because there's stuff that already exists from the previous compile. So it does appear to be done. So we'll right click, reveal in File Explorer. We'll double check over here. You can see the date and time of the last one. So we'll go back, we'll right click, and we'll send to the actual D drive. So if you go back over to the D drive, we now have the new build. So we can now go back over to the workbench, pop out the drive, plug it in over here, and this time we actually don't need the jumper to load it. We can just plug it in and let it load. But I wanted to show you both methods so you're aware of it. So let's go back over to Pronterface, and inside of Pronterface we're going to have to connect again. We're going to double check the actual status. It's still okay. So we're in the center. So I'm going to click the actual home button this time just so you can see how it works. But at this point, I want to thank all of my patrons as well as people on PayPal for all of their donations to keep this going so I can purchase new components to show you new tutorials. And so let's see what happens. So it's homing and it softly touches. So if you like my tutorial, please press the like button, and that will let me know how much you like it, as well as YouTube. And I'll put a thank you in the end for the patrons as well as the people with PayPal. So everyone take care, be safe, and I'll talk to you later.